Good morning. Okay. First of all, what's happening on Friday? Does anyone remember? So today we're going to do the matrix operations, basically just multiplication. Friday, I'm doing makeup exams, so we're not going to have class. I've also got a 8 o'clock appointment somewhere else, so uh, don't come to class on Friday. I won't be here until later. If you contact me about the makeup exam, it'll start at 9 o'clock. Okay, so I'll be using my office hours for that. The rest of you, what I really encourage you to do is get through 5.1 and 5.2. 5.1 shouldn't take you too long. It's look over the video if you hadn't seen it, but it's just the process for adding, subtracting, and transposing. At the end of that lecture, we talked a little bit about using the calculator. We're going to see today, we're really going to want to use that calculator or a calculator that does matrices. So again, if you don't have one, you do have one. So just a reminder here, NumWorks, N-U-M, as in number.com. You can download, well, you could use it on your computer, so you can try it online. It's pretty intuitive to use, and they're a new company. You can actually buy a handheld one of these for $99. So if you like it, uh, it's not bad in its color and everything else. It's got a nice little menu. First of all, I don't get any kickbacks from them, so I'm not. But they're just, I used it. It's different, so you have to get used to it. But it's a little bit more intuitive than the TI-84. It'll do matrices. It'll do everything the TI-84 will do, plus more. Uh, so if you don't have one, I encourage you to use this. You can also download it to a mobile phone. And if you've got the right size mobile phone, it'll look exactly like this. And the button pushes will work exactly like a calculator. Okay, it's not a touch screen. It's not like, so it'll work just like the calculator. So, but you've got to get used to using a tool. Oh, I can get by. Yes, you can, but you're going to see today why it might be beneficial. Um, I will, since again, a lot of you do have the TI-84, I will be using the TI-84 matrix features. I'll show you how to use all of these. In fact, let me start by, I've been playing with some things. Um, can't remember which, I don't think any of these I need. One of the things I had to look up was how to delete them. And again, I just Google delete matrices on TI-84. Somebody made a nice little video. The way you do that is second mem. Yes, you could go over the top, but you can go to memory management, which says delete. There's something called matrix. That's where we're going to go. And then what it does is it shows us all our matrices. It doesn't really tell you what to do, but if you hit delete, now matrix A is deleted. I'll just go ahead and delete them all because I can't remember what's there. But you can clear them out this way. But that's not intuitive. Again, I had to look it up. I thought it might be in there, but anyway. Uh, so again, second, it's the X to the -1 button. It says matrix above it. We're going to use this quite a bit today and from here on out for this section. So by test time, you're going to want to have access to either the TI-84. Casio will do this as well. I have one at home. I don't use it much, but I could help you figure out if you've got a Casio calculator. And then the NumWorks, if you don't have any calculator, I'd encourage you to use it. And once you get using it, I think you might want to just go ahead and order it. I think they can get it to you in like 5 days, $99. I think it's free shipping. Might have to pay tax, I'm sure, but get something or borrow it from a friend, but don't borrow it the day before the test and then try to figure out how to use it. Oh, the calculator will do it. You got to enter them in. So you got to get it from your friend now or your brother or sister, whatever you're going to do. Start using it as you do the homework. Okay. So that's where we're going. Friday's kind of a space day. What I did is I took where we were going to have a quiz. I moved things around, and so that gives us that free day. We'll still be able to get everything done. We'll still have 2 full days of review. And remember, I think I'll go here. The first one, I'll have like a short practice test. We'll go through that so then you can kind of see, and we'll see how that helps. All right. Any questions, comments, concerns? Happy Valentine's Day. A few people in red, so that's good. Should have wore red. I don't have any red. Oh well. Anyway, happy Valentine's Day. Okay, so actually, what I'm going to do is take exam one. I'm going to shrink it down because we're not going there anymore, right? We're done with it. Uh, Here we are in matrix operations 2, focusing on multiplication. So let's go ahead. There's a full PowerPoint with all the wordage and everything. I use sort of a shorter one so that I can talk you and walk you through the concepts. Okay. Matrix multiplication. And I forgot, in this class, we're only going to look at one type of, so we looked at scalar multiplication. So we'll talk about that just briefly, where basically it was just distributive properties, a number times everything in the matrix. So we did that first part. Today's going to be a little bit more complicated, but there's actually 2 types of multiplications with matrices. We're only going to do one. The other one involves vectors, and it's kind of like the engineering application. Business doesn't really have much use for it, so let's not even talk about it. At least I don't think so. I looked over the content on the surface. I don't see the other type, and I remembered. Oh, that's right. That's only in vectors. So we're going to first take a look at two simple matrices: a row matrix and a column matrix. So row matrix, remember, has only one row, and a column matrix has only one column. So the example we're going to look at is, say we paid $10 to download 3 movies, and then we downloaded or got 5 Chopin albums. Actually, I thought that was Choplin, which is a comedian, but Chopin is a musician. I used to play orchestra in middle school, so, but classical's okay, but I like jazz better. Anyway, so we can think about how would we calculate the total cost, right? So thinking of this, we have 3 movies at $10, 5 albums at $8. So thinking of 3 times 10 plus 5 times 8 should get us, I mean, that's that situation, right? Seems simple, right? I'll buy 3 of these for 10, 5 of those for 8, multiply and add. What we just did is actually a matrix operation. So we're going to set this up as if it were a matrix, and we'll see how that works. But that's how matrix multiplication is it's actually, we're going to multiply 2 numbers, but we'll have a list of things we're doing, so we're actually going to add them. And so these 4 numbers actually combine in a way where we multiply 2 of them and then add the result together. 30 plus 40. So we spent $70, like they said, but we want to put it in a row. So what we're going to do is put the price in a row vector. First one is, and a lot of times they don't label them, but the $10 must be for the movie. So every movie we download is $10. And then the 8 is signifying the $8 cost for the albums. So that's the price matrix. The quantity matrix, we'll do it vertically. And we're going to see there's a reason why we have to do this vertically when we do multiplication. But we set it up, we bought 3 of the first one, 5 of the second. Okay, and we're going to see that these line up, that a price matrix, quantity matrix. And so we know that the result is 70, and we know we took 10 times 3 and 5 times 8, because that's how the problem just went out, right? So when we do matrix multiplication, we take the row times the column. So the first item in the row times the first item in the column, And then we take the second item in the row times the second item in the column. If we had more items, we would continue, but we take that whole row times the column. So kind of maybe like thinking of it as sort of inverting and multiplying. And then for each of these, right, 10 times 3, we did that. That resulted over here, 8 times 5. And then we add those multiplications together. Okay, so that's where it is not purely multiplication. We're having to add them together. And what we end up with is just a matrix that has only one item. We don't end up with a, see, we started with a, what's this? This is a columns first, a rows first. This is a 1 by 2. This one is 2 rows by 1 column. Okay, I'm going to jump ahead a little bit. When we multiply these two, what we ended up getting is a 1 by 1 matrix. And you're going to, we've got another example, so we'll take a look at that. So this is kind of the overview. If you can kind of say, okay, this is the process. It worked because we did it just reading a story, and that seemed to make sense, right? 30 times 10, because that's what we bought, or 3 times 10, and 5 times 8, because that's what we bought of each. That was the cost. It makes sense, right? If we set it up this way, this is how it has to work. And we're going to see that the nice thing about matrices is we can kind of leave behind the connections. And when we have a lot of things, sometimes that's where we get confused. We got 5 different items, and getting them all lined up can be difficult. But if we follow this process, we'll be able to do the multiplication of the two. Okay. Questions so far? How's this looking? Not too intimidating? Good. So it's just a multiplication and addition. So it's technically nothing difficult. Again, the hard part of all of this is getting it organized, keeping it organized. And that's where I would mess up. But because these are going to get bigger, but that's okay. We'll be fine. It's just a, and as they get bigger, we'll also be able to check it with our, well, we could check this with the graphing calculator. Um, in fact, let's go ahead and do this to kind of verify. And so that I want you to get used to seeing sort of the steps multiple times. And this is when they're small enough, I can do this. So we go to the matrix. Names is when we've got a matrix ready to use. That's where we're going to pull it up, and I'll show you that in a moment. So the first thing we're going to do is, these are all the math things. We'll do some of these a little bit later. We're going to edit or enter the matrix. Okay. So I'm going to put in A. So A doesn't have anything right now. I put enter, and I want to do a 1 by 2. I want to do that first row matrix, right? So it's going to be 1 by 2. So I have to give the dimensions. And again, the nice thing is if I transposed it, I put it the wrong way, it's, oh no, I want a row matrix, not a column matrix, right? So the tools do help. I want to put 10 in for the first entry, enter, and it just jumps to the next one. That's kind of nice. And what was it, $8 for the albums. There's my row matrix, okay? And again, just I get used to moving around. Then I need to go back to matrix because I want to put in a second matrix, right? So I go second matrix, I think. Oh, good. And it takes me here. I'm looking at A. Again, I have to go over to edit, down to B because I want to edit B now. And now I want to put in a 2 by 1. So I put a 2 and a 1. And there I have a column matrix, right? Column matrix. And what goes in here? This was, I bought three of the download movies and 5 albums. So that's what I put in there. Okay. So now I've got my B matrix. I've got my A matrix and my B matrix. Now watch this. This is kind of cool. You're going to see. It's not so hard. What we do now, second, I don't know, there might be another way. I do second quit because I want to get back to sort of the main screen of the calculator where it does all its calculation, where I could do like 3 times 5 equals 15. So I'm at that screen. Watch, I can do matrix multiplication here too. I go second, not second math, second matrix, go down far enough. I'm going to take A times B, A, and then I just put the multiplication the calculator knows it's a matrix and it knows how to do matrix multiplication. A times, I have to go back to matrix B. And I hit enter, and what am I going to get? 70. We knew that, right? And so it followed it knows how to do it. So this is kind of cool because we can do it. We'll learn how to do it so that we know the process. And then we'll, for the most part, when we have a big, hairy problem, we'll use this to get that answer, but we'll be able to follow along and maybe even verify, okay, it multiplied this, this, and this, and that's how it got that, okay? We'll do a little bit on our own, but this is how we do matrix multiplication with the technology. You just have to enter the matrix, and we come to the main screen, and then we can start working with it. Cool part is this is how we use most of the other tools as well. So again, we're going to be using these on a regular basis. So get comfortable with the technology. Take a little bit of extra time, play with it, because the more you use it, you build sort of a muscle. Your finger actually, your little brain in your finger knows more what to do than you do. You get to where you don't have to think so much, okay? Because you've practiced enough. But when you don't practice enough, and then you think, I know a way to do it, but I forget which buttons to push, which ones to do. So it takes some practice, and even I do over time. It's been a while since I've done matrices. I had to spend some time. Oh, okay, yeah, I remember all this stuff now. Okay, so far so good. Okay, so now that's basically the lesson today. If you got that part, all we're going to do is do some more examples, go a little bit deeper. Row times column, each one, boom, 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 add them together. You've got that. You've got that value. It gets a little bit different when there's more, more rows and more columns, but we'll see. Oh, well, no, I'll just keep going. Well, actually, yeah, I don't, I'll keep moving. Okay. So, we end up with a 1 by 1, basically going from the row to the column and adding the results. Okay, so that's the process. And we're going to see how this works with more things going on. So we're taking the product of AB is a row matrix A and a column matrix B, 1 by 1. And we're going to see that the length of the row A must match the length of the row B. Does that make sense? Because if you're going to take each of these and multiply them, if you had 5 here and only 4 there, then you don't have a partner to work with. You don't. It's not fair, right? So everybody has to have a partner. So whatever length this row is, the column has to be that same length. One's shorter, you'll have something, hey, these guys can't multiply. The calculator will tell you a dimension error because the sizes aren't right. Remember, a lot of times with matrices, when we add matrices, we need them both to be the same size, right? Because we're just adding entry by entry. Well, if one's bigger, then there's nothing to do with these. You can't really add it. So same thing with multiplication. The rows of one have to be the same length as the columns in the other. And we'll see that it's kind of what I did here is this 2. This 2 and this 2 had to match up. If that 2 was a 3, the other one would have to be a 3. So if it was a 1 by 3, we need a 3 by 1. Okay, so when we're multiplying and we put the dimensions together, we'll see this middle number always matches up. Okay. Here's a 3 by 3. Sorry, what's this? This is a 1 by 3. And we're going to multiply it times a 3 by 1. And again, you'll notice these dimensions in the middle match up. The 3's match up. Because I need to take the first row times the one in the column, this one and this one. So all 3 are getting multiplied, and then we add them all together, right? 4 plus 40 plus -1 gives us 43. And we could think of that, because that's what it is. It is a 1 by 1 matrix with the answer 43. Let's just do this one while we're here. So we're going to take 2 times negative 3. And I encourage you maybe the first few times you do this to kind of write it out. And then 1 times 1. So 2 times negative 3 gives us negative 6. 1 times 1 gives us 1. Those are two ones I have trouble because sometimes I'll take 1 times 1 and I'll say it's 2 because I'm thinking addition, right? I might take 2 times 3 and think 5 because I'm thinking addition. So for me, it's helpful to write these out so I can catch an error. And then we add the results together. Negative 6 plus 1 will give us negative 5. Oops, I guess I didn't have the answer, but that's what, and again, it's a matrix. It's a 1 by 1 matrix. Uh, so far, so good? Okay, we'll keep moving. Product of a row and a column. So far, we've had the row is on the left and the column is on the right. As long as the dimensions are right, we can do it either way, but we're always, when we're multiplying, we're taking the row times the column. What we're going to see is matrix multiplication is not commutative. You cannot just change the order on it. Sometimes you can and it'll still work, but you'll oftentimes get a different answer because things are happening differently. So when you change the order of the multiplication, A times B is not going to generally be the same as B times A unless in a very special case. Okay, so order is very important when we're doing the multiplication. Order is very important. And we'll see a few examples and we'll see, yeah, when we change order, we don't get the same answer. Sometimes we can't multiply in that other order because the dimensions aren't right. Okay, the row size has to match the column size. So we've already talked about that. So however long the row is, that column has to be that same length, right? So that's that middle dimension if you put them together by doing their dimensions. And we'll see, because we can do more than just a single row times a single column. We could do something that has 2 or 3 rows times something that has 3 or 4 columns. It just gets messy. Okay, and so this, can we multiply this? Good. No, because we've got 3 things to multiply, A, B, C. We only got 2 things to multiply it by, so someone's left without a dance partner. That's not nice on Valentine's. Everybody should have a dance partner, right? So, no, we can't multiply this. This cannot be multiplied. You enter it into your calculator. Again, it won't like the letters, but if those were numbers, your calculator will tell you, nope, can't be done. Dimension error is what it'll tell you. Okay, not defined. Okay. I left this in here. We're going to go through this, but they talk about the ijth row. So what they're talking about is in a matrix, remember, we had entries, and let's say this entry here, it's I tells us which row it's in, and the J would tell us what column it's in. So I kind of refers to the row, J to a general column. So we're always taking something from matrix A in row I gets multiplied by column J. And again, I find it harder to talk about and easier to just, let's look at some examples. So here we're going to move a little bit, a next step of difficulty. We still got a row matrix with just one row, right? A 1 by 4. So we've got a 1 by 4, but this time we're going to multiply it by a 4 by 3. And are the rows, sorry, yeah, is the row matrix as long as the column matrix is high? Yes, they're both. So we're going to have enough partners from the row to multiply the 4 in the column. Watch this cool part. Can anyone predict what the, well, I guess they gave it to us. Can you, the end result they gave us, I'm going to show you how they got there because that's all the stuff. They ended up with a 1 by 3 matrix. And can you see that 1 by 3? It's sort of the 4s cancel each other out. Yes, sir. Exactly. exactly. This is a good way to, they explain it a little differently, but that's exactly, the fours kind of, we're going to, because we're multiplying them and turning them into a single number, we always end up with the outer ones. So if it was a 2 by 4 times a 4 by 3, we'd end up with a 2 by 3. So we're going to do one of those as well. Uh, and again, what this notation is this is actually row 1 times column 1. There's a lot going on there, right? And let's just take a look. What's going on there is I've got to take 2 times 1. So I'll just, 2 times 1 plus 0 times 1 plus -1 times 0. And again, some of these maybe you could do in your head, I guess, but oops, I don't know why I do that. I said 0 and for some reason I wrote 8. I still have not figured out how my brain works, but I've figured out I have to watch it. And then I add 3 times -3. So you see, right? Sometimes that's where my problem is. I get sloppy and I don't write them down nicely. 2 times 1 is, there's 2, there's 0, there's 0, and that's -9. So if I add all those together, I'm going to get -7. And that's the first entry here in our answer matrix. Okay. How do we get the next one? Well, they take row 1 times column 2. So row 1, because that's all we got, now we do the same thing, but we multiply by column 2. So again, it's kind of tedious, but let's do it. So I've got 2, which came from here, times 1. And then I've got 0 times -6. I'll just kind of write it out so there's kind of evidence of what we're doing. Then I've got -1 times 5. And then I've got 3 times 8. And yeah, that's where the calculator is going to be nice. It could just do it like that. We quite can't do that. And faster we go, sometimes the more mistakes we're going to make. Again, we just, okay, 2 times 1 is 2. I like the zeros. That gives us 0. -1 times 5 gives us a -5. 3 times 8 gives us 18. Add them all together. So 2 and 18 are, wait a minute, what did I do? I'm getting a different answer than they did. Oh, 3 times 18 is, 3 times 8. See, I did 3 times 6 in my head. 3 times 8 is 24. So sometimes it's nice. That's where it's nice to have the calculator to do this, because you'll wear yourself out, right? The brain just, it doesn't want to, it says, I've done enough. It's simple multiplication, but I can't remember the right stuff. Not 18. It is 3 times 8, 24. Okay. So 24 and 2 is 26 minus 5. That gives us our 21. And that's this one right here. See how that works? And then we take that row times the third one, same thing, multiply, 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 add, add, and we get that third last number of -15. Okay. Again, our calculator will do it, but it doesn't show us what it's doing. It's doing the same thing, but it'll give us a matrix answer like that. So we all good? Just prepare it. And again, the thing I found out, what I liked about this course, I was linear algebra, so that's all we did was matrices. And so we did a lot of stuff with matrices. It taught me to give myself space and to, you know, use my scratch paper in an organized manner. So that's what I got out of that particular class. It was also very frustrating because we'd have larger matrices, and even the simple process of multiplying and adding, you can see one error somewhere in here. We got one term off. We could have had one of these entries, and so it's wrong. And then trying to find that error could be difficult. Even if you know the answer, where did I make, okay. So far so good? Okay. And again, we could enter this in. The calculator will do it. I think I'll wait till I get something a little bit more complicated. We could have, again, this takes another level of difficulty. So now we're dealing not with just a single row, but with two rows times something with two columns. So again, what we have here, the first one is the dimensions are 2 by 2. The second one is 2 by 2. The middle twos sort of cancel, and we end up with one that has the outside ones, which is going to be a 2 by 2. So that's a nice thing working with square matrices. They work nicely because you keep a square matrix under multiplication at least. Okay, and so what you see happening here is row 1 times column 1, and then row 1 times column 2. So the rows go, row 1 is always going to be used on the first row, and then row 2 gets used on the second two. So it's almost, you could think of separate things. So how did we get this number -2? Again, kind of complicated. We took row 1 times column 1, so that was a 1 times 3. So I'm going to that was 1 times 3, and then we're still in row 1 times column 1, so we're taking -1 times 5. -1 times 5. So that gives us 1 times 3 is 3. -1 times 5 is -5. 3 minus 5 is -2. That's how they got it. So is that clear? We're taking row 1, multiplying it times column 1. And that's going to give us one number in that first spot. This one, we're taking row 1, so just these numbers, times these numbers. So you see it's kind of, you got this, one's a row, one's a column, and you got to match them up. So visually it's a little bit harder to do, but I got -1 times 0, or sorry, +1 times 0, and then -1 times -1. 1 times 0 is 0, -1 times -1 is +1, and there it is. Okay, so, and again, this is very challenging if you have any sort of a transposing type brain that works, which I do. And sometimes, again, it's not a, I don't like to think of it as a disability, it's just, it works well some places and not others. And so when you're able to think backwards and forwards, that's sort of a superpower sometimes, but not here. It's kind of, it makes things confusing here when we're, you know, taking a row times a column. But think of it, it's a row times a column. Okay. And then when we get to the bottom one, again, we're using, let's go with red. We're using this row times each of these columns. Okay, a row times a column, row times a column, and that would give us our answers for each of these. Okay, so let's take a look at one of those. So this first spot to get 10, right? How did we get 10? Well, we took 0 times, let's see, first one. Okay, we took 0 times 3, and then we take 2 times 5, which gives us 0 plus 10, which gives us 10, and that's what goes right in that spot. Okay. How we doing? Questions? Okay. So rows on the left, columns on the right. It's always how it works. And here's what we've already been talking about. If you write out their dimensions, and some of the homework problems, that's what it starts with. It says, here's two matrices. What is the result matrix? What's the result dimensions going to be? So you don't actually have to do it. You just have to say, put them next to each other. The middles have to match, and the new dimension basically cancels out. We're going to get a 1 by 3 here. These match. These are going to cancel out. We get a 2 by 2. Okay. How about this one? Let's do a 5 by 6 that way times a 7 by 5. What would be the dimensions of that new matrix? Don't think too long. Can we do that one? Yes, that one. Can that be done? No, because they don't match in the middle. The first one has 6 things to multiply. The other one has 7. There's going to be someone's left without a dance partner. Okay, so first thing we always look for, can it be done? We look here. Oops. Nope, this can't be done. Not defined. Can't multiply it. Cool part is we're done with it. Just can't be done. That's it. So they got to match. If they do match, then it's the outside ones that will give us the new dimension. So just be able to write the dimensions. And again, that came from Mondays, and it's a simple thing, but it's also very simple to change, right? And that's my, depending upon how you look at things. Row to column. I have to physically get my mind to think that way. When I do graphing, I'll read a graph in both directions, and that causes me problems. When I'm thinking of problem solving, I have to think I have to go left to right. And I can't let myself go right to left. Maybe, so same thing with this, row to column, row to column. Some of you may be just fine with that. And again, but it just depends. We each work differently, how we think. Okay. And so that's just verbiage basically saying the middle parts have to be the same. If they are, we can multiply it. Those cancel out, and we know the dimensions of the new matrix. And that's kind of helpful because then you're going to end up with a 1x3, especially if you're doing them by hand. You put them in the calculator, it will tell you and it will take care of all that for you. But in the homework I looked over, they ask you to do it both ways, especially even with the bigger ones. Now, for some reason, they set it up. I can't, as a teacher, I can't work through them, but I sort of see it looks like what they do is they have you show your work, show you the matrix that you're coming up with, and then the final matrix. But anyway, so you'll let me know how that all works. Okay. And this is just, don't think too much about this, but if we had something really long, this is basically just saying we could have had a larger matrix, so we have more rows, more columns, but each time we're multiplying for a particular, notice, a particular entry in the answer matrix, whatever that's going to look like. In this case, they give a m by n times an n by k. And these are just variable numbers. They could be any size. As long as these two dimensions in the middle match, we can do the multiplication, and the resultant one will have m rows and k columns, right? And each individual entry here, new entries, well, I shouldn't use A, I'd be getting let's call it C, matrix C. So it's the answer matrix. So C would be equal to this. Each little entry here is going to be the result. This would be the it would be the the ith row of the first matrix, the j column of the other matrix, and it gives us a single answer. So even if they're really long, remember we're multiplying and then adding them together. We're getting a single answer for each of these. So it's just take a row times a column, row times a column, row times a column, and you get all the different entries. Okay. Don't worry too much if this isn't, it's very abstract. Again, we'll keep looking at the concrete ones and working through some examples. So we've got 2 of these. Not a lot of time, but what I did is I left in the process, and again, we'll just kind of look at the process. They chose some relatively easy numbers to deal with, right? We don't have 2.6 that we have to multiply, and it's a mess. So these are not too bad to work with. So the first one, again, and notice they've changed on us. We're doing a column times a row. Can that be done? Well, this first one is what is that? That's 2 rows by 1 column, right? The second one is 1 row by 2 columns. Are the middle ones the same? Yes. So we should be able to multiply this. What kind of a matrix are we going to get, though? We're going to get a 2 by 2. So this is a little bit different, but we're going to watch. We're still going to multiply row times column. Row times column. Okay. So this gets a little challenging, but we'll take a look at this. So this is a 2 by 1 times a 1 by 2. And yes, we're going to get a 2 by 2. So the way this works, row 1 times column 1, it's actually simple. Row 1 is 3. So this number is going to be negative 3 times column 1, which is just 2. Nothing more to do. Negative 6 is our answer. This one here, again, row 1. So this times column 2, negative 3 times 1 gives us negative 3. And then we come to row 2 times column 1. That's going to be down here. 1 times 2 is 2. And then row 2, which is here, is still 1 times column 1. 1 times 1 gives us that 1. Okay, so it can be done the other way, but we're still, when we multiply, it's row times a column. Row times a column. And we, as long as the dimensions line up, those middle dimensions, we're okay. Okay. So this one, let's check. We get a 2 by 4, a 4 by 3. So the middle ones are matching up. That's good. We can do this. And what's the resulting matrix we're going to get? Our answer is going to be a 2 by 3. So when we get this, we're going to have 2 rows, 3 columns. Okay, so that's what that states. And we'll just kind of go through this. And again, what it's doing, and you'll do this a few times, but it's taking this first row times this first column. And again, it's going to line it up. It's 2 times 1 plus 0 times 1 times negative 1 times 0 times 3 times negative 2. Multiply and then add all those together. So you can see you're going to need some scratch paper over here, right? To get just this answer here, so we'll do that 2 times 1 plus 0 times 1 plus 0. Oh, actually, I'll do it in the right order. Minus 1 times 0 plus 3 times negative 2. So this is the work that's going into it. 2 times 1 is 2, 0, 0, and then 3 times negative 2 is negative 6. 2 minus 6 is negative 4. So that's how we're going to go through and verify it. So again, nothing overly technically difficult. It's the organizing and seeing what's getting multiplied. This is one that's definitely going to be good to be able to put into your graphing calculator and get the answer and match it up. Again, we could keep going through it. And so this next one, notice we stick with row 1, but now we move to column 2. So we do the same process, but we take 2 times 1, 0 times 0, negative 1 times 5, 3 times 8. On our scratch paper, add all those products together, and that's what goes right here. We're going to get 21. Do the same thing here, row 1 times column 3. Stick with this one, and we take this one. So you can see it's just repetitive, right? But very technical. And one little error, taking 3 times 8 and saying it's 18 instead of 24, that blows everything up. But the good news is if we are careful, we might be able to catch, and again, writing them down. I found out that's what I have to do is I think I'm good with mental math, and I am, but my mind just likes to play tricks with me and throw out random wrong answers. So I write it down so I can catch those wrong answers. In the last couple minutes we have, let me just walk through. Oh wait, let's see. Well, maybe if you want to stick around, we can do that. I want to get to the last part. So this gives you some stuff. Um, we've got square matrices, and square matrices are nice. There's something called an identity matrix. An identity matrix has one along the diagonal. Whenever we multiply something by an identity matrix, what happens? What happens when we multiply by 1? 5 times 1 is 5, right? A million times 1 is still a million. Nothing happens when we multiply by 1. When we multiply by the identity matrix, nothing happens. So you say, why do I need it? Well, we'll see that we're going to be using this, but this idea of an identity matrix, and it's because there's these zeros here, basically cancels out. It's these ones here that make the matrix basically stay the same because we're going to multiply. Again, we can only use it if we have a square matrix, right? We can only multiply a square matrix times the identity matrix because the identity matrix is square. And we could have a 5 by 5, and again, the key part is ones along the diagonal. Okay, so if we have this, and if we were to, again, you could go through the process, right? Row times column, row times column, row times column. And you'll see the first one you'll get A, the second one you'll get B, the third one you'll get C. We're just about done. So we'll pick, what we'll do is on Monday, I'm going to pick up because we don't use it too well. Actually, let me just show it to you real quick, because this is where we're going. There's some properties. We'll look over those. Transpose, but the part I want to get you to, so you can look over these. I don't think you have anything, but order's important there. This is the last one, and this is one of the reasons we use the matrices. We take a matrix times the x, y, z, so that's 3 dimensions. Basically, we are able to set them up. If you do the multiplication, which this is a 3 by 3 and a 3 by 1, you're actually able to get a system of equations. And notice these coefficients, the 1, -2, 3, those are the coefficients from the matrix A. So what we're doing is basically, we're actually going to go the other ways. We're going to take these these system of equations, we're going to turn them into a matrix. And then we don't have to work with the letters. We do matrix. Our calculator will actually be able to do all these calculations. Okay. So we're going to come back to this, but this last setup is just, if you multiply these two together, you get this system of equations. If you say it's equal to B, right? This is a 3 by 1. This is a 3 by 1. They're the same size. If these are equal, then each of these is equal to these numbers. Okay. So there's some in the homework with that. What I might do is work a few examples so that over Friday you can keep making forward progress. Same thing happens if you have a system of equations. How can we turn it into a matrix? Can you see that we're going to have a matrix here that is 2, 2, 1, and 4, -1. And then we're going to have this matrix here, oops, sorry, x and y, and it's going to be equal to these answers over here. So that's how we can use this matrix. And again, what we're going to see is down the road, we take this matrix A, and we'll be able to figure out what x and y are by basically turning it into the identity matrix. This is what we're going to do. But that's, here we're just setting it up. Okay. Sometime next week, we'll get into actually, we're going to be able to solve for x and y, what they are, just using matrices rather than equations. So this last part is turning matrices to equations, but that's not the really important part. The part is being able to turn the equations into matrices, because that's what we'll use later on. So again, we got crammed a little bit on this, so I'll take a little bit more time and maybe post a post video for this, and we'll keep moving forward. So Friday we won't be meeting, but I'll have a little bit more for you to take a look at as far as this last part, and send me any emails. that you have. I do have office hours now. Um, so just keep building on this and then we'll start using it next week. Thank you. All right, you too. Okay, so you go to memory, so second memory, and then you want a memory management, which has to delete, and then you want to go to matrix, and then just hit the delete button on the ones you want to clear out. If you want them all, just hit delete, yeah, and it's gone. And then yeah, the problem is you don't get a look at. You have to look at them in advance, but it's not really convenient, but it works. Sure. Thank you. You too.